Here's the content for the rest of your study guide for robotics. Looking at whiskers circuit having 5 volts running through, and when it contacts it, it measures 0 volts. So let's go ahead and see what's happening with this whisker setup here. So your wiring system looked something like this. We had a wire coming from the 5 volts, and then it came down, and then it went into a pin number. We also had the whisker connected to the circuit as well, and it was like a little on-off switch. So when the whisker is not contacting, the voltage actually travels from the 5 volts to the pin. In this case, the pin is acting as an input, not an output, meaning it's measuring how much of the voltage is being received at the pin, whatever pin number it may be. So the voltage is going here, and if the voltage goes here, it's going to measure all 5 volts at the pin, and it will then read a 1. So 1 means no whisker is being touched. However, when you touch the whisker and you actually contact this over to this circuit, the power then flows down this way, and it goes into the ground and returns to the battery. So if the power is going this way, that means it's not going to the pin, and the pin is going to receive 0 volts. So if it shows up as 0, it means the whisker is contacted. So the whisker is pressed in this case. So again, we have these two possible scenarios where we have the 5 volts, okay, and it's going towards this whisker, or it can go to the ground. So there's two possibilities. One can go to the pin, and one can go to the ground. And when the whisker contacts, the voltage goes to the ground, and no voltage goes to the pin, it receives 0. When the whisker is not contacting, all the voltage goes into the pin, and you then will show a 1, meaning nothing's being contacted. So what does all this mean? If we have a left whisker and a right whisker, if we have a 1, 1, this means that nothing is touching. So I'm going to just say no touch. If we have a 0, 0, that means that both whiskers are touching. If we have a 0, 1, it means that the left whisker is touching, but the right one is not. So for this, we have a left touch. And for the 1, 0, this means that the right is going to be touching. So what are you going to code for each of these scenarios? Well, if the whisker, if there's no touch, we want the robot to continue to go forward. If both of the whiskers touch, we want to then, if it's 0, 0, we want it to back up and then turn. So we have a back and then turn. If we have a 0, 1 and the left whisker is contacted, that means we've hit something on the left-hand side. We want to back up and then turn right. If we contact something on the right with the 1, 0, the right whisker is contacted, we need to back up and then turn towards the left. So those are the 4 different scenarios that you can have with those whiskers. Now, just regular motion without the whiskers, forward motions, and left and the right servos. So just to remind you, here is your bot, and here are the wheels. This, of course, is your left, that's your right, this is the back ball. And when it's going forward, it's going to be having a speed of 1700, 1300. You can look in chapter 2 for your speed charts, and not your speed charts, but your motion charts. And that's what you should be looking at. Forward motions and left and right servos. So forward is going to be 1700 for the left and 1300 for the right. So what's a swivel motion for clockwise and counterclockwise? So swivels, if you remember, these have the same numbers. Both the left and the right have the same number. So let's take a look at a clockwise swivel. So clockwise is going to be going around like this around the clock. Well, what's going to enable this to move like this? Well, if this is 1700 is forward and 1300 for the right is forward, I want the left to go forward and I want the right to go back, meaning I want the opposite number. So I want it to go like this, and that's going to be 1700, 1700. And likewise, if I want to go counterclockwise, opposite of the clock, I want my right to be going forward at 1300, and I want this to be going the opposite. So it's going to be going like this. And so it's going to be 1300, 1300. Now when you have pivot motions, pivots are always going to have one is going to be 1500. Not both, but one. If both of them are 1500, then it's going to be stopped. So one's going to be 1500. So how do I make this go clockwise? There's two ways that we can make it go clockwise. If this wheel is stopped and this is going forward like this, it's going to be pivoting around in a clockwise fashion. So we can have 1700 and we can have 1500. Now, we can also have this one stopped and this one going around this way, going backwards as well. 1500, but what's this number going to be? This is going to have to be the opposite of 1300 because 1300 would be going forward, so it's going to be 1500, 1700. Both of those would code for a clockwise pivot. Now how about the counterclockwise? Counterclockwise going like this. So I can have this one stopped at 1500 and this one going forward, and it would be a counterclockwise going around like this. So this could be 1500, 1300. Likewise, I can also have this one stopped. This could be 1500 stopped, but how do I make this go this way? Counterclockwise would be going around this way, so it's going the opposite of forward, it's going back, so that would be a 1300. All those scenarios would be for various types of pivots. Speed chart encoding for full speeds and slower speeds and stop. So let's do the speed chart over here since we have a little bit of space. Okay, and we measured distances and we measured speeds on this chart right here. So this is in reference to 1500, 1500. So if you have plus or minus 200 from 1500, 1500, you have 1700, 1300. You're going full speed ahead. Even at plus or minus 100, when you're at 1600 and 1400, that still is full speed going ahead. This is your full speed zone. So 1700, 1300 would be the same as 1600, 1400. It would be going full speed. It's not till you hit this zone right here. This would be plus or minus 0. This is going to be 1500 as your reference point. So this would be 1700, 1300, 1600, 1400, 1500, 1500. And of course, at 1500, 1500, it's going to be stopped. But this is going to be called your linear speed zone. So if you want to go forward slowly, you would have the plus or minus maybe around 50. So you would have, instead of 1700, 1300, you could have 1500 and 1450. So if you want to go forward slow would be something like 1550, 1450. It's very close to 1500, 1500, but this is still above 1500. This is still below 1500. Now let's say I wanted to do a right turn, or even a slow right turn. Okay, I want it to turn off towards the right, which means I want this going forward but slow. So let's pick a speed that's going to be slow. 1600 is not going to be slow. So let's have this as a little bit less than 1600. Let's try 1550. Okay, oops, 1550. Okay, now we want this one going forward because we want to turn it to a slow right, but we want it going a little bit slower, because if we just had 1550 and 1450, it would be going forward slow, but we want this one to be going faster. We want this one to be going even slower. So this one's going to be going at a very slow speed around here. We would need something to go even slower, which would be right about here. So here's my 1550. I would need something right around here. Okay, so this would be something like 1475. This is 50 away from 1500. This is 25 away from 1500. So it would be going a little bit slower. And this effect, having a faster wheel and a slower wheel, would slowly turn our vehicle off to the right. We're not going to be doing the function of resistors on this test, but I would like to describe the IR sensors and the setup for that. And it's very similar to what's happening in the whiskers. We have your IR LEDs and your IR sensors. So let's go ahead and do a little drawing just to remind you and show you what's happening here. You have an IR LED that is emitting light that we can't see in the infrared zone. And it's going out and it hits an object. Let's just say it's a wall. And then that bounces back to the receiver. It's the IR receiver. Okay, so we have voltage that is going to the IR and it's turning it on. So we have two different setups that are going through here. We have a 5 volt that is coming out, and then this is going to the IR LED, and then that then goes to the ground. This is just to have the light work. Okay, so it's coming from the 5 volt, goes to the LED, provides the power to send out this infrared signal going all over the place. But we also have a receiver, and the receiver is actually going to be on the input. So here's an output right here. we also have an input, so we're going to be attached to some type of pin. So we also have voltage coming from the 5 volt, and it's going to the receiver, and from here it can go 2 places. It can go to the pin, or it can go to the ground. So it's a little bit like the whisker setup that we have right here. So when the receiver, if it receives a rebound, well, let's say it's not receiving any rebound. If it's not receiving any rebound, what's happening is 5 volts is going to be going to the pin. And if it's going to the pin at 5 volts, that means that the receiver hasn't received anything, and it would say, okay, I'm receiving all of the voltage. However, if all of the power then goes to the ground, okay, the pin is going to be receiving 0 volts. And so it would record that as a 0, meaning that there's an object in front of you. So it gets diverted towards the ground instead of towards the pin. Again, when the pin doesn't receive the voltage, it records it as a 0. So if the IR sensor is recording 1, 1, it's just like the whisker. Okay, we have the 4 scenarios. 1, 1 means that there's nothing in front of you, so there's no object whatsoever. 1, 1 is no object. 0, 0 means that there's an object right in front of you. So we do see the object. 0, 1, just like the whiskers, means the object is on the left. So here we'll say object in front, object on left, and then 1, 0, this would be the object is going to be on the right-hand side. So if there's no object, all of the power goes to the pin, records it as 5 volts, it stores it as 1. If it does see an object, then the voltage is then not going to be going towards the pin, it's going to go into the ground. It's going to be, so therefore the pin is going to be receiving a 0 signal because 0 volts is coming in. So what do you code for when either avoiding or whether chasing? Okay, so I'll give you a couple scenarios. If you're trying to avoid an object, okay, and you have a 0, 0, okay, that means the object is in front of you. What do you want to do if you're trying to avoid the object in front of you? You want to go back. So you're going to be going backwards, which is the opposite of your 1700, 1300. It's going to be 1300, 1700. If you're trying to chase the object and it's right in front of you, you're going to go 0, 0. You're going to have a 1700, 1300. There are other scenarios. What if you have a 0, 1 or a 1, 0? Well, you have to figure that out based upon this right here. Okay? If it's a 0, 1, your object's on the left. If you're trying to avoid it, you want to turn to the right. Do a swivel of 1700, 1700. Okay, if you're chasing it and your object is on the left, you want to go towards it and swivel towards it with a 1300, 1300. What a QTI does, a QTI detects black and white. In this case, black is equal to 1 and white is equal to 0. So our standard is 0, 1, 1, 0. This is going to be going forward. Okay, if we have this scenario like this, that means our line is actually to the left and we're veering off of that. So we need to actually turn towards the left. So we'd want to swivel it like this and turn it towards the left. So we want to turn left. If it's 0, 0, 1, 1, then that means our line is actually over here. We want to turn to the right. There are a couple of other scenarios as well. And what happens if you have a scenario like this? You have a 1, 1, 1, 0. And in this case, you've come upon your left-hand turn, and you'll need to then swivel to the left. Or if you have 0, 1, 1, 1, you've come up to a 90-degree right, and you want to then swivel to the right. Okay, code for LEDs using digital write, high and low. There's a couple possibilities for this. Both can be on, so it would be high and high. Both could be off, and that could be low, low. And we can also have a scenario where they alternate, where one's going to be on, one's going to be off. So remember, high is on, low is off. Also for this problem, pay particular attention to the delay of whatever it is, 500, 1,000, 2,000. This tells you how many seconds or milliseconds that the lights are going to be on, or how many that they're going to be off. Code directions using servo left, servo right with microseconds between 1300 and 1700. So again, this is relating to the linear speed zone. Of course, if you're going forward, it's going to be 1700, 1300. Okay, forward is 1700, 1300. Back is going to be 1300, 1700. Okay, what's a right turn going to look like? A right turn is going to be something like this is going to be going faster, such as we described right here. So you have to know this linear speed zone right here and be able to answer a question based upon the scenario. Okay, so remember, full speed is going to be, full speed for something is going to be between 1700 and 1600 for the left, and between 1300 and 1400 for the right. And the linear speed zone, where it's going slower, is going to be between 1600 and 1500 for the left, and between 1400 and 1500 for the right. Coding for pivots and swivels and whether they're clockwise or counterclockwise. I think we did all the scenarios over there previously. And coding for the tones using a pin, a frequency, and a duration. So for example, if you have like a 3 2,000 for 3,000. And following this, there's going to be a delay of 3,000. This is going to hold that note for the duration of the 3 seconds. Then if you have a 3, 1,000, 2,000 for a delay of 2,000, how would you describe this? Well, this is the frequency, and the frequency is indicating the pitch of the note. The higher the number, the higher the pitch. So you would say the speaker would have a high pitch for 3 seconds, and then it would have a lower pitch for 2 seconds. And if it's the setup, it just happens once. And if it's in the loop, it gets repeated over and over and over again. That's it for the review. Don't worry about this because we're not going to be doing that coding on the QTI track. Please let me know if you have any questions.